Let's look at this problem. I have f broken into different pieces. I have f in the x direction, f in the y direction, and f in the z direction. So I have to find out if f is conservative or not, of course. How do I find it? Well, with the del and the cross product, the force. So I'm going to have x direction, y direction, z direction, and then the d over dx, d over dy, d over dz, and then f of x, f of y, and f of z. So let's solve this. We're going to get x direction, so x hat, d over dy of f of z, minus d of over dz of f of y, then plus y hat direction, and we're gonna get d over dz, the f of x, minus d over dx of f of z. And then the last one will be z direction, and then will be d over dx in the of f of y, minus d over dy of f of x. So by solving this, I'm gonna get x hat direction, for example. I'm gonna get d of what is f of z? F of z is equals to ay plus bz squared over dy minus d over f of y, which is az plus 2bxy over dz. So let's solve one part at a time. Let's solve this first one. So I'm gonna get x hat that is equals to a from the first part minus a from the second part. So they cancel each other out, and I'm gonna get a 0. Now for the y hat instead, I have d of f of x, which is ax plus by squared over dz minus d of f of z, which is ay plus bz squared over dx. So we're going to have from the first one, off with y ahead, the first one we obtain 0 minus the second one that obtain 0. So this one is equals to 0. So far it's looking like it is conservative force. Then z direction, I'm going to have the d of f of y, which is az plus 2bxy over dx minus d of f of x, which is ax plus by squared over dy. Oops, dy. So z hat, and then for the first one, I'm gonna get 2by minus 2by, which is of course they cancel each other out, and obtain that the answer is actually equals to 0. So the cross product of the del operator would have our force F is equals to 0. Therefore, F is conservative. Now let's imagine I have a second force. Let me rewrite the different components. So F of x is equals to ay, F of y is equals to az, and F of z is equals to ax. So now what I'm going to do is the same thing. So del operator, del cross product. So let me just copy and paste this thing because it doesn't matter how you're going to do it. So it's going to be the same thing. So I'm going to have, for the hex direction, I'm going to write it in one single piece this time. F of z is ax over dy minus d of f of y, which is az minus dz. Then plus y hat, and d of x is d of, which is the for x, okay, ay over dz minus d f of z, which is ax over dx. Parenthesis plus z hat, which is then going to be equals to the d of f of y, which is az over dx minus d of f of x, which is ay minus dy. So I'm going to get out of this is for the x hat, I'm going to have 0 minus a plus y hat, which is 0 minus a again, plus z hat, which is 0 minus a again. So our answer will be negative a x hat plus, minus a y hat minus a z hat. And that is the solution to our cross product with a del operator. Therefore, our f is not conservative. So our first force was conservative because the vector product is equals to 0, but our second force is actually not conservative because the cross product does not equal 0.